So to simplify questions like this, which is root 98 minus root 8 over root 50, what we normally do is break them down into perfect square and imperfect squares. So what I mean by that is, so as you can see, each of the simplification, root 98 is the same thing as writing 7 root 2, root 8 is the same thing as writing 2 root 2, root 50 is the same thing as writing 5 root 2. We did that by first of all breaking them into perfect squares, like 49, 4, and 25 are all perfect squares. Then the imperfect squares, things that we cannot square root to give you a whole number, which is 2, we understand that we had to multiply 2 by each and every one of our perfect squares. Then next, we just had to break them, so we can rewrite it as 49 times root 2, 4 times root 2, root 25 times root 2, and the simplification is what we have: 7 root 2, 2 root 2, and 5 root 2. We can rewrite our answers here to have 7 root 2 minus 2 root 2 over 5 root 2. Now you need to take root 2 like x. If you have a question that says 7x minus 2x, you would say the answer is 5x. And that's the exact same thing you're going to do in this particular question. So since you have 7 root 2 minus 2 root 2 is the exact same thing as writing 5 root 2 over 5 root 2. And final step is by cross-cancelling, we understand 5 will cancel 5 out, root 2 will cancel root 2 out. My final answer will just be 1. And that's it. 3 minus root a over root 2 plus 4 plus root a over root 2. Now all this squared, we're trying to simplify this. To simplify a question like this, because it's in fraction form, the best method is to find your LCD. Now, since the denominator is the same, we have a common denominator for both our fractions. So writing that out, we would have root 2 as the denominator. Then all we just need to do is fit in the numerator of both our denominators. So we would have this. So now simplifying the numerator, you would get, now assigning squared to both the numerator and the denominator, this will give you, and therefore your final answer would be 49 over 2. That's it. Okay, so we have this question that they want us to prove. You can either prove the left-hand side is equal to the right-hand side, or you can prove vice versa, proving the right-hand side is equal to the left-hand side. But because I have the most information on my left-hand side, and it will be easier to simplify, I would recommend you prove the left-hand side is going to give you the right-hand side. Now, before we do the proofs, there are a couple of things that you need to put at the back of your mind to answer this. The first thing is, so root x times root y is equals to the root of x times y. Now the second rule you also need to know, using difference of 2 squared, x squared minus y squared is equals to x minus y, x plus y, right? So put this at the back of your mind while we answer this question. The first thing we're going to do is we're going to use the first concept. So we're going to write it like this. So now because there's a multiplication here and you have a square root, we understand that this can be written under the same square root. Now the second thing we can do using the second concept is whenever you have the subtraction and the addition of two variables, you always perform difference of two squares. This here would give you so now simplifying this, you'll get and therefore, as you can see, the answer is equals to b, the square root of a minus 1, which is exactly what we needed to prove. That's it. So this question says we need to prove the 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the square root of 40 is equals to 120. Now to prove this question, we need to make the left hand side equals to the right hand side because obviously it's easier. Now how we do that is by breaking each of our roots. So let's try as much as possible to break it down. And this is what we can do. Now I did this because I noticed a trend. I noticed that for each of our roots we have a 10. And that would definitely come in handy in answering this question. Okay, so let's simplify it a little bit further. Now all I did here is I noticed 64 can be rewritten as an exponent. So that's rewritten as 2 to the 6. So is 81 can also be written as 3 to the 4. And 4 can also be written as 2 to the 2. Now this helps me simplify it a little bit better because whenever you have a root and an exponent, if they are the same, they kind of cancel out. So this is what you're going to get. Okay, so the next step we can do here is now change our root into exponents. Because the problem is we can't really do anything with this root as it is. So to make it a little bit easier, I'm going to change each of my roots to the exponential equivalent. So now we can multiply the numbers 2, 3, and 2, and the 10, 1 over 12, 1 over 6, 1 over 4, 1 over 2. Now since they have the same base, we normally add the exponents. So what will happen is this here should give us and therefore the final answer will just be 120, which is exactly what they wanted over here. Yeah, so this is exactly how they wanted to go about answering this question. And that's it.